So here we have a classic torque problem, and in this case what we have is two people pulling on a vertical pulley and they're applying different forces at different angles, and we need to work out the net torque. So I always encourage my students, and I encourage you to do that when you do problems as well, is to make a diagram of the situation, because that's going to really help us into determining correctly what the torque is doing. So here's my pulley. And we know that the diameter is 20 centimeters, so therefore automatically my radius here becomes equal to 0.1 meters. Of course, correct SI units. We have two forces being applied. The first force is in this direction like so, and it's 100 newtons, and the angle here is equal to 30 degrees. The other person is applying also a force, in this case at an angle of 45 degrees, and it's 120 newtons, and we're asked to work out what is the net torque. Now the first thing you need to do is to determine what you determine is to be the positive direction. So I'm going to make this my positive direction. I could be wrong. That is, if I work out the net torque and I get a negative value, we know it's going to start to turn the other way, but let's see what happens. Now torque is of course equal to the force multiplied by the perpendicular radius, in other words the moment arm. So in other words, maximum torque is of course actually acting in this case here, but because this is not actually at that angle, we need to have a component. But what is the component? We know this is 30 degrees, but the angle we're interested in is the angle between that direction and the moment arm, so that it's actually this angle here. That is, that angle here is going to be, in this case, equal to 60 when we're using the correct formula, because the torque is equal to the force multiplied by the moment arm multiplied by the sine of the angle, and the angle is the angle I'm talking about here. It's not 30 degrees, it's 60 degrees. Now a way to think about that is this. If this becomes 90, then as a result the other angle here is 0, and that means the sine of 0 is equal to, well, what is it? 0. So we get no torque whatsoever. Whereas if it's perpendicular, my angle is actually 90. Well, the sine of 90 is 1, so we have a maximum torque. So think of it that way. So in our situation, we have the net torque is equal to the two torques applied. In this case, we have this torque, which is equal to 100, multiplied by my radius, multiplied by the sine of 60. We subtract the other one because it's going in the opposite direction, so it's 120 multiplied by 0.1, and then the same thing here is the sine, but of course this is 45, so is the other one, so we get 45. When you calculate that out, you're going to get 0.175, and the unit of course is Newton meters. So you can see I have a positive value. I was actually correct, but really it's pretty balanced almost. It's a very small net torque in this case, and depending on what the moment of inertia is of our pulley, which is related to its mass, then the angular acceleration you get will probably be relatively small, but it's certainly going in that direction, and will continue to accelerate in that direction as long as these angles are maintained and the forces are maintained. That's not necessarily true, of course, but that's the case there. Now, last thing, of course, is the direction. So I have to say it's going in a clockwise direction. Torque is a vector, so make sure you give both magnitude and direction to your final answer. In any case, I hope that's helped you understand the classic torque type problem. I'm Paul from High School Physics Explained. Take care. Bye for now.